Hello, this is the project submitted by Loganathan K and Srijit T of batch number 24. They are using e-health system for smart hospitals using IoT. So basically their project is for comatose patients. You see, for comatose patients it is a lot of expense for their family or their loved ones to take care of them. I mean, we have no guarantee of when they will rise up at all, but the average cost of sustaining a coma life in hospitals may exceed like more than 5 lakh per month. So it is very expensive for the guardians of the family. So in most countries, mercy killing is what they could do for comatose patients, but there are still chances they might come back to life. So by this project, they're implementing a low cost system, like a uh, low cost but e-health system, which helps to reduce the hospital costs, and by using the system in the home itself, the patient's home itself, we can reduce the hospital fee, that is the patients monitoring the patients and
This is load better than the hospitalized cost. As we can see that this is our project and by using Raspberry Pi.
Okay, wait. Okay, so they are using a Raspberry Pi module. Let me show you. This is the Raspberry Pi module. A Raspberry Pi is a product of is a single board computer developed by Raspberry Foundations in UK. It has 1.2 GHz, a 55 cortex processor, and a 1 GB of RAM. It is pretty much like a single board computer, and they are using pulse sensor here. As we know, pulse sensor is used for detecting the pulse of the patient or pulse of the not victim, the patients. And then we are using an DHT11 module, which acts on both temperature and humidity sensor. Then we have this ADX 345 module, which this is nothing basically but an accelerometer, which will give us values when there is any change or there's any change in moment. So, and yeah, here we are using an MCP3008 ADC. It is nothing but an analog to digital computer. Out of the sensors, this DHT1111 and ADX135 is a digital sensor, and pulse rate is an analog sensor. So we have to, and Raspberry does not support any analog pins as of now, so we have to convert the values to digital values. That's why we are using the MCP3008 ADC for this pulse rate. So the program is basically based on the psychological factors. For composition, the first thing or the first we can see the specification of Raspberry Pi in the monitor. The Raspberry Pi is connected to a monitor via the HDMI cable and HDMI to VGA converter, so we can see the output of the Raspberry Pi in the monitor. Wait. So now we are going to look at the working of each sensor. Pulse sensor.
Pulse sensors.
Okay.
We are going to sense these pulses.
Okay, and we are going to run this program.
And we'll be muted from here. It is something with confidential.
Okay.
Okay. Thank you.
Okay. As you can clearly see, we are getting temperatures 30 degrees Celsius, that is the room temperature as of now, and we are also getting humidity 95%. It's and we can also see the timestamp of when this is taken. So come on, since we have no other additional source, I'm using a lighter to show you the change in temperature. So as we know, the previous temperature value is 30 degrees Celsius. Okay. Change yeah, As you can see, the mind is changing 31 degree. The temperature is rising to 31 degree Celsius and 32. Okay, stop. As you can see, the temperature is clearly rising from 30 degree to 31-35 degrees due to the heat from the burner. Now, if the temperature gets above a certain degree, that is 40 or say 50 degree, then we can alert the nurse and we can alert the hospital staffs, and they will come to our house and take care of the medicines. Medicine. Okay, on. Okay, next we are going to see the ADH345 sensor, which is an accelerometer sensor, which will give you the change in direction or change in movements. If the as the psychological factor says that the most if the patient is a left-handed person or right-handed, this is dominant, and the first movement will be the first movement, even the slightest movement will be on his hands. It is set. So we will attach this accelerometer on the patient's dominant hand, and say since this is in rest position, you can see the code. You can see from the code, you can clearly see that when we run the program, we get the values of 78. This is the default values. I mean, as of now, the accelerometer is in rest. Now if we change the values, if there is a moment detection, you can see there is a huge difference in the values. From that is 78, x equal to 78, y equal to minus 26, and is equal to 245. We get the value now x equal to 221, y equal to 130. So even for a small change, there is a big change in the values here. So we will compare the values with this our initial values with these new values. Through this we can identify whether the patient has done some slight movement or anything. Okay, and when the accelerometer is moved slightly, then we will alert the respective doctor or anyone through email. We are using an email module to that. Let me show you the email module. Pausing. So as I told you before, if there is any change in the moment, the accelerometer will notify us. And if there is any change in temperature, or if there is any change in BP, that is if the patient's BP get low or if the patient's BP get high, then if the patient's body temperature get too high, or if there is a slight movement in his dominant, and we will notify the hospital or the authorities, that is the home nurse or a doctor, via email. Let me show you the email. This is our email code, where kl9avenger@gmail.com is our proxy. How to say, it's a proxy email. This is our server email, so we can consider kl9avenger@gmail as the IoT health IoT systems main email, and we are sending the data to Loganathan K. Pillai, who is currently the let's say is the guardian of the patient. So from this you can see we are attaching a log file. The log file is nothing but all the values. As you can see, all the change in values here are noted into a log file, and the log file is sent along with the email. Okay, let me show you the working of the final module. Yeah, we are using Python. Every code in this module is done in Python. As you can see, this ADH, DTH, and LS, system, MCP308, and module. As you can see, there are a bunch of time files. These are all part of the EL2 system, and we are running the main file now, that is ls. Okay, as you can clearly see. Okay, just a pause. Starting. Yeah, as you can see, at time 9 the pulse rate sensor is 60 bpm and body temperature is 45 and the moment is pulse. So as you can clearly see from this log files, yeah, by the time we changed this we made a movement in this area 135 sensor, we get a coma patient sudden movement, that is this movement value becomes 2, and we get sudden movement of coma patient sudden movement is observed, and we have alerted doctor. The alerting doctor is via the mail, yeah, okay, but the mail is sent to the doctor or the nurse, via which we can alert the doctor that there is another movement, and also the doctor can fully check the patient's ppm, body temperature, and movement at any time at 05 0054 is 1254. So at any time we can the doctor or the respective authority can check the patient's details. Okay. So that's all for the project of login as an anesthetic K. That is EL system submitted by organized an anesthetic. Okay. And okay,